All right, moving along. I'm delighted to introduce our next speaker. Nir Minerbi is here. He's the co-founder and CEO of Classiq. He's going to talk about from concept to circuit, building real quantum applications with Classiq. Join me in welcoming Nir.
Hey, good morning. So, should I use this one? Let me know if needed. Good. So, I'm going to focus basically on how we use quantum computers, right? How we build software and applications for them. I'll start with saying that it's pretty hard, and then after 20 minutes or so, we will understand that actually not really. That's the main goal of the next 50 minutes or so. But let's start with why quantum. Well, it's the second day. We are kind of mature already, so we understand that. But the one thing to understand is all of the computers we are familiar with, right, from our iPhones, laptops, to the most powerful supercomputers, they have the same DNA, right? They work pretty similarly. Some are stronger, some are weaker, but they work the same. Quantum is very different. Quantum is an alien, right, with totally different computational DNA, let's say. And that was the initial motivation for creating this new era in computing. And today we know, this is work by McKinsey, specifying different use cases across different industries, and with potential value creation of trillions of dollars. So we have motivation. We have motivation to build these quantum computers. The why now is interesting because this field is being discussed since the 80s, right? So why this is the right time for the maritime industry or for any other industry to get involved? Because a lot was happening and is happening in the past few years, right? We see big progress by many different hardware vendors, whether it's IBM or Google or Microsoft or Quantinuum and governments and startups and academia. They all build these machines with amazing progress, right? And we have good reasons to be very optimistic as an industry that in the next few years we'll start seeing commercialization and productization of quantum applications. And what's really interesting, and it relates to Raghu's question a couple of minutes ago, is why enter now? I think there are a couple of reasons, but the main thing here that quantum today is where AI was a few years ago, but it's completely different, right? AI is part of classical computing. This is a new era in computing, something that takes place, well, once in 70 years or so. So I think starting early will have huge benefits. And this is what we see, right? We see big enterprises across different industries leaning forward, establishing quantum application teams, and develop their internal IP, proficiency applications. We see governments, entering some kind of quantum arms race, establishing national quantum strategies, building quantum computers, buying quantum computers. And that's great. I think that the momentum is great. One of the key challenges is how to use these machines. Why it's a challenge? Because there are several reasons, but one of the key reasons is, all of these machines are very different. Some build them with ion traps, some build them with superconducting qubits and photons and, diamonds. There is no one architecture. But another reason is there isn't any software stack, right? When we established this company 5 years ago, so the similarity was kind of, interesting. Actually, what you see on the right, this is what we call a quantum circuit. This is quantum software. So basically, the way you develop quantum applications 5 years ago, in some cases also today, is specifying gate-level operations. Okay, that was more beautiful than my slides, but yeah. So the way you develop quantum applications is at the gate level, which is much lower than assembly. This is almost a NAND level, right? So that's a challenge that should be solved. And if you specify more concretely what are the key challenges, first, very, very low-level programming, gate-level programming. The second one is scaling up, right? Even if you take world-leading quantum experts, they can't really build applications for thousands of qubits. This is just something you cannot do at this level of abstraction. And the third one, which is obviously a challenge, is hardware adaptability, because the code you design for the IBM machine won't work for the Quantinuum machine or for the quantum machine. So portability of quantum code is very important. And this is what we do, right? This is what Classiq was established to do. We build an operating system for quantum computers that takes the programmer end-to-end, right? We allow them to develop at a very high level of abstraction, almost like classical coding, very easy, and I'll show you a short demo in a few minutes. Then we take care automatically of the compilation. We take the high-level functional model and we compile it into different hardware architectures, and we let you run it on any quantum computer, get the results. Now, it solves these three challenges. First, the programming is very, very high level. You see one example of the QMod language at the bottom. Very short code, very abstract code that allows you to develop the most sophisticated quantum applications. The second one is scalability. Our core technology is design automation, right? Like we use in the classical, chip design world, tools like Cadence, Synopsys, that allows us to scale into chips of billions of transistors. This type of technology is what we use to scaling up quantum software to hundreds and thousands and then millions of qubits. And the third one, which is also very important, is being hardware agnostic on the one hand, because you don't specify the circuits, you specify the functionality, but also very much hardware aware, because this is what the compiler does, right? It takes this high-level functional model and it cross-compiles it into different hardware modalities. And eventually, it's deeply integrated on top of any quantum computer, any quantum cloud, any hybrid quantum HPC framework like NVIDIA CUDA-Q and HP Cray and the Intel Quantum SDK and so on. So really, there is no lock-in, and it allows basically anyone, and this is very important, the quantum experts, but also software engineers, domain experts, it allows them to become quantum developers pretty easily, and I'll show you that in a few minutes. So I think my key message here is adoption of quantum applications made much, much, much easier if you use the right platform. So this is what we do. This is our mission. A little bit about the company. So the company was established 5 years ago. We raised $180 million. Today we are a team of 95 global team. We have offices in the US, in Tokyo, in Europe, here in the Middle East as well. Here in the UAE, we work closely with the Vernwell group, investors, both corporate investors, financial investors, and eventually we are here to serve the industry, right? Because the platform is dedicated to the industry. It allows enterprise, also academia, also governments, teams to develop their quantum applications. And now I won't focus specifically on the maritime industry. I want to give you, spread examples from what different industries do in quantum with us. Maybe it will spark some ideas for this specific a unique industry, and I think there are many similarities. So let's start from finance. So generally speaking, the finance sector is very active in quantum. We see several repetitive use cases. One of them is quantum optimization for portfolio optimization, for example, very relevant for the maritime industry. There are some huge computational challenges, optimization problems here. And any small improvement could worth billions of dollars. So this is an interesting one. The second one is a quantum Monte Carlo for improving precision and speed of these kind of simulations. Another use case we see a lot, this one by HSBC, is combining quantum and AI, quantum machine learning, in this case for fraud detection. Again, with better precision, training with less data, and so on. Different industry, automotive and aerospace. So I think this one is very relevant for the maritime industry, both for a manufacturing of better ships, better equipment, and CFD, which is very relevant for Rolls-Royce, for example. Imagine that in a few years, Rolls-Royce will be able to design engines that consume 10% less fuel. That could be dramatic, and we are limited today with classical computing because CFD is so heavy on compute, and quantum could be the solution. Okay? Another industry is energy and chemistry, right? So work done with CERN and with Mitsubishi on quantum chemistry, the discovery of new materials, new sources of energy, green energy, also very relevant for this region, obviously, with the need to find sources for renewable energy and so on. So definitely quantum chemistry could be one of the solutions. Almost the last one is the healthcare industry. Also, big opportunity because both for material discovery, drug discovery, and also for modeling, brain activity, also mainly with quantum machine learning models, and great potential relatively for near-term advantage. So this is something many hospitals and research centers are focusing on today. And the last one I want to specify is the telecommunication industry that is also seeing interesting use cases both on network optimization and also on the cybersecurity side of, let's say, patch management optimization, post-quantum cryptography, and so on. So these were several examples of what very different industries do. I think the common ground for all of these industries I showed is nothing, which is beautiful because this is exactly why we know that in the maritime industry we'll find so many relevant use cases for quantum, because eventually you have big, significant computational challenges that could be solved with this new type of computing. So the exploration is very important, specifying exploring the right use cases, and this is the phase one of your potential activity. And this is the reason we are so happy to partner with the Vernwell group. We jointly created a white label version of the Classiq platform with the look and feel of the Vernex platform. And now in this short video, 2 minutes, I'll try to be silent. I won't succeed, but I really try to show you how very easily you create quantum application, initially with high-level modeling of a quantum algorithm, and then also with quantum vibe coding, embedding AI within the quantum framework. So you see that it's quite easy, and I really encourage you to do that by yourself. I hope the video will work. Let's see. Yeah, it's working. Okay, good. So this is the Vernex quantum platform. You go to the platform, then you have the modeling environment. I told you that I won't be able to really be silent, but I really tried hard. So here you have many applications for different industries, right? We focus on one that looks very simple, just arithmetic, right? You want to embed this arithmetic expression into quantum program. See that even though the code was very simple, 5 lines, the actual circuit that was automatically created is pretty complex, right? Try to design this at the gate level. It's challenging, very, very challenging. Then you want to run it. You can run it on any quantum computer. Let's say you want to use the IBM Marrakesh machine, right? You see the outline, the functional qubits on the chip. Then you can run it. You get a result. And now in the next phase, I want to show you how quantum vibe coding looks like. And here actually the use case will be a maritime use case, just a toy model but showing. So let's say we want to optimize shipping routes for 5 cargo ships between Abu Dhabi, Singapore, and Rotterdam, minimizing fuel and so on. Now, out of this very simple prompt, you'll see that significant quantum code, in this case for the QAOA algorithm, will automatically be created. It takes very shortly. By the way, it's all trained on the Classiq application library, which is a big application library with hundreds of quantum applications. This is what allows it to be so efficient, right? So out of this very short description, it creates tons of quantum code that later could be run, simulated, and so on. So this is just an example, but it shows you really that it's not so complex. It's about using the right methodologies, but your knowledge as industry experts is all is needed to become quantum engineers. So that's it. If we have time, happy to answer any questions. And yeah. Thank you.
Nir? Don't be shy. Questions, here we go, yeah.
Hi again. So thanks for the talk. I enjoyed that last part especially a lot. So one question is, so this reminded me a lot of the IBM cloud interface, what the team around Qiskit and IBM is doing, right? So they also came up with, or they tried to do a universal protocol called Cousin. You know that?
Mm-hmm.
You interface with this to kind of like have a more global reach on hardware.
Sure. We generate CAS and we also generate other outputs, you know, QIR and so on. The big differentiation is we start very high level. We start at the model level. You can think of it as you know, Verilog for quantum. So we specify the functionality and also the hardware constraints. Then the technology is EDA, right? Design automation that takes into consideration both the functional model and the constraints, and it has big design space of possible implementations. With Qiskit, basically you specify the optimization. You specify the circuit with very small, you know, you leave the transpiler very small room for optimization. We leave the compiler big room for optimization so it can choose the best circuit. So you see that comparing these, you know, platforms you mentioned, you will usually see between 70 to 97% of improvements in terms of gate count and so on. Happy to show you after.
Yeah. Other questions? Steve?
Yeah, hey Nir, well done on your company. You guys are doing amazing work. Tell me what's exciting that you guys are going to be looking at over the next 2 to 3 years. Maybe even talk about your growth expansion plans.
Thank you, Steve, and great to see you here. So I think what we find most exciting is seeing more and more industries, more organizations entering quantum. And what's really big in my view is they always start the same with the same algorithms, the same use cases, but then after they become proficient, they know how to develop their own applications, they come up with applications we didn't imagine. That's amazing because eventually the killer applications will come from the industry itself. So this is what excites me most. From our perspective, so you know, we are here to build the technology to serve the market. We expand to more markets. It's wonderful to work here in this neighborhood. And yeah, I think these are, and of course, hardware progress. You know, without it, we can speak a lot, but you know, do not so much. But I think that there is amazing momentum, and there are going to be big news, I think, in the relatively near term.
Great. Just gentlemen.
Yeah, thanks, Nir. Not many people have said that quantum programming is simple, so you said it, so thanks for that. Maybe one question is, you showed your, like the offering and the software really well, but what kind of an effort is taken on the customer side in cleaning up the data, storing the data, and then ensuring that it's compatible with the data? So how much time does it take, how much effort does it take for enterprises to start, assuming that they say, yes, we want to work with Classiq and we want to take your software, what happens on the back end? Thanks.
Yeah, so the first thing they do is short training, you know, and the training is exactly what you mentioned, is how to take your classical data and load it into a quantum program, into a quantum circuit. Then, you know, both on the pre-process and the post-process, it has anything to do with assimilating it with the enterprise current existing workflows, right? It's not quantum separated, it's integrated within their workflow. So I would say that after 2 months, they are proficient in developing quantum applications, and after 4 months, they have their first almost production-ready quantum application. It's relatively fast because it's deeply embedded in the workflows. It's Python, it's easy to use.
Thanks.
There's time for one other question. Anyone else want to pose a question? No, we're good? Okay, well, thank you, Nir. Fantastic. And connect with him on the break. We're going to take a short coffee break now, right? Stand up, stretch, get some more coffee. It's going to be about 20 minutes, so come back here at 11:20. And we have several other fantastic keynotes lined up. I also want to mention that there are 2 tech tracks that are going on. If you're not familiar with that, these are sort of more detailed, granular conversations about tech-specific topics. There's one at 11, and they're in the auditorium, which is left, right, all the way to the end of the hall, and then the left. There's one at 11:15. Jitesh Lalwani, founder and CEO of Artificial Brain, is going to give a talk on the use of satellite data and quantum computing for maritime efficiency and sustainability. It's a 30-minute session. After that, at 11:45, there'll be another tech track. Eugene Olejnik, head of the customer team at Kipu Quantum, is going to talk about the Kipu Quantum Hub, unlocking quantum advantage for maritime logistics and education. So those are going on down the hall, starting at 11:15. Let's take a short coffee break, yeah? And we'll see you back here in 20 minutes. All right, thank you.